All right, let's jump right into this explainer. Today, we're decoding the anatomy of an evidence-based environmental management system, specifically zeroing in on ISO 14001-2026 Clause 9.1. If you're involved in environmental compliance, you already know that having good intentions simply isn't enough anymore. You need proof. So we're going to unpack exactly how to build a robust, evidence-based monitoring and measurement program.
Here's our roadmap. 1. Data, the EMS feedback loop. 2. What, how, when, and who. 3. Ensuring equipment calibration. 4. Maintaining data integrity. And 5. Common nonconformances. Because this standard is highly structured, following this outline is going to help us deconstruct Clause 9.1 into really digestible, logical components. Let's get to it.
Section 1. Data, the EMS feedback loop, or proving your environmental promises. Let's start with the big picture and look at how monitoring data acts as the absolute vital signs of your organization's environmental health. Without it, well, you're essentially flying blind.
So I really want you to ask yourself this high-stakes question. How do you actually prove your environmental goals aren't just empty promises? Under the 2026 standard, an EMS literally cannot rely on assumptions. It requires hard, scientific evidence. You might have a beautifully written policy statement declaring your commitment to the environment, but when an auditor walks in, they're going to ask for the data. They want the numbers that prove your operational controls are actually working.
This quote nails it. Monitoring and measurement represent the essential feedback mechanism that enables organizations to understand whether environmental objectives are functioning effectively. Data collection isn't just busy work, you know? It's the fundamental feedback loop verifying that your controls prevent harm. The standard is incredibly clear here. Environmental performance cannot be managed effectively without reliable data and systematic evaluation. It is the engine of your continual improvement.
Moving right into Section 2, the 4 pillars of monitoring, which covers the what, how, when, and who. You see, before taking a single measurement, you have to build a core framework. You can't just go out and start testing things at random. Clause 9.1 strictly requires these 4 specific pillars to ensure your environmental data is collected systematically and, most importantly, aligned with your highest risks. 1. Determine what needs monitoring. 2. Define how to measure it. 3. Establish when monitoring occurs. And 4. Assign who is responsible. If you miss even one of these pillars, your entire environmental performance evaluation becomes incredibly vulnerable. Let's break these down, starting with what. You absolutely must isolate the exact parameters that matter most. If air emissions are a significant aspect of your operations, you have to measure specific pollutants, like particulate matter or nitrogen oxide. Running a water treatment facility? Then you're looking at things like pH, turbidity, or biological oxygen demand. You have to measure the things directly linked to your highest risks and compliance obligations. And look at the massive difference between a vague objective and a compliant one. Saying you want to reduce energy usage sounds great, but it is completely unauditable. Clause 9.1 demands a measurable indicator. So a compliant objective would be to monitor monthly electricity consumption in kilowatt hours per production unit. That way, you can actually track if your performance is improving or deteriorating over time.
Next up, we have how and when. You need scientifically valid measurement methods at frequencies that actually match the environmental risk level. High-risk processes, like stack emissions in a power plant, require continuous digital sensors because a deviation could cause immediate environmental harm. But a lower-risk issue, like potential soil contamination near a storage area, that might only need quarterly laboratory sampling. The frequency absolutely must match the real risk, not just what's convenient for the schedule.
Finally, the who. This means assigning specific trained personnel, like certified lab technicians or environmental engineers, to conduct and interpret measurements accurately. The crucial point here is that even the most state-of-the-art monitoring equipment is totally useless if the personnel assigned don't have the precise competence to interpret the data. If you put a production supervisor in charge of monitoring hazardous solvent emissions without specialized training, your data will be inaccurate and your compliance is on the line.
All right, Section 3. Technical enablers, specifically ensuring equipment calibration accuracy. Once your framework is built, we have to zoom in on the technical side of things.
Because you can have the best plan in the world, but if your thermometer is broken, your data is garbage. This brings us to calibration traceability. This insider term simply means ensuring your measurement results can be linked to national or international standards through an unbroken chain of calibration comparisons.
It officially proves your equipment's accuracy, which is exactly the evidence an auditor needs to trust your data.
If we put on our lead auditor hats for a second, there's a very specific checklist we use. We actively look for the calibration date, the approved calibration method, reference standards used, measurement uncertainty values, and of course, the pass or fail results. If your certificates are missing these details, or if they're expired, the auditor just cannot trust any of the data that instrument produced.
Zero. Literally zero. That is the exact margin of error ISO 14001 gives for using uncalibrated data. Because measurement uncertainty can easily mask a severe regulatory violation. Think about it. If an uncalibrated emission sensor happens to underestimate pollutant concentrations, you might think you are fully compliant, while in reality, you are actively violating your permits. Zero margin for error.
Which leads us to Section 4, the truth in the numbers, which is all about maintaining environmental data integrity. Moving past the physical equipment, we really have to safeguard the digital lifeblood of your EMRS.
You have to consider the massive risks of vulnerable data practices compared to compliant ones. Manual spreadsheets, unbacked up files, systems using shared logins, auditors find these all the time, and they are massive red flags. If data can be accidentally deleted or quietly altered, its integrity is totally gone. Instead, you need compliant practices, digital sensors, secure cloud backups, and access-controlled audit trails.
So, you have to ask, is your automated environmental data actually secure against rising cybersecurity threats? As we rely more on digital sensors and automated monitoring, protecting this data from hackers or system failures is crucial. If your continuous emission monitoring system is transmitting real-time data to a central database, you've got to have cybersecurity controls in place. A hack that alters emission values to conceal non-compliance, that's a modern risk clause 9.1 forces you to anticipate.
And finally, Section 5, the auditor's lens, where we'll look at common monitoring non-conformances. Knowing the insider secrets on how organizations typically fail this clause is the best way to make sure you don't.
These are the top audit failures we see: missing calibration records, testing frequencies that are simply too low for the actual risk, a total disconnect between the objectives and the indicators. But the biggest trap of all, failure to analyze data for trends. Organizations will literally collect stacks of environmental data just to check a compliance box, but they never actually evaluate the trends to see if their controls are working. Data without analysis is just a storage problem.
The main takeaway here is that robust monitoring transforms an EMS from a reactive compliance burden into a truly strategic, evidence-based asset. When you rigorously apply the what, how, when, and who alongside strict calibration, your EMS stops being a paper-pushing exercise. It becomes an engine for true sustainability. You transition from just hoping you're protecting the environment to scientifically proving it every single day.
So I'll leave you with this final thought. If your environmental data was audited today, would it reveal a strategic asset or a massive compliance liability? Take a hard look at your organization's vital signs and ask yourself that question, because the data never lies. It will either prove your commitment or expose your vulnerabilities. Thanks for joining me for this explainer on ISO 14001 Clause 9.1. Go check those calibration records, secure those workflows, and I'll catch you next time.